Hello friends, welcome to my channel Master the Monster. Let's enter into the world of polynomials. Trust me, this is going to be an easy and interesting section of mathematics. You may have few doubts and questions regarding polynomials, the degree of polynomials, zeros, division of polynomials, what are quadratic polynomials, geometric meaning, all those things in your mind. No worries, let us sort out all the questions one by one. Before that, subscribe to my channel so that you will enjoy learning maths. Let's start with the definition of polynomials. But before knowing what are polynomials, we need to know what are variables and constants. So first let's see the definition of a variable. A variable is nothing but a symbol that can take any real value. So variable is a symbol and you can assign any number to that symbol. Okay, and it also can change while you execute the problem. And the symbols we use to denote variables are x, y, z, like that. We use some symbols to denote a variable in the problems, right? So variable is a symbol that can take any real values. Similarly, constant. Constant, unlike variable, it don't vary throughout the problem. It just has a fixed value. So constant is a symbol which has a fixed value, and we use some symbols to denote constants like A, B, C. So few alphabets we use to denote variables and few alphabets to denote constants, right? Okay, now let us consider an expression of the form a constant into a variable. So you have an expression of the form constant into variable. That is an expression like A into X, B into Y, or 5 into Z. See, in all these cases, you have A is a constant, X is a variable. So a constant into variable. Like that, B is a constant, Y is a variable. 5 is a constant, Z is a variable. So let us consider expressions of this type, that is a constant into a variable. Sometimes we also have expressions of the form 2x, x square plus 2x, or x cube square plus 4x plus 7, all those things. Okay, sometimes in terms of y. So whatever it may be, whether it is constant into variable or like this you have sum of some terms. So all these are just polynomials, and particularly they are polynomials in one variable, because see here, the first term is, the first expression is ax. Here there is only one variable, namely x. When you consider 5z, here the variable is z and no other variable, right? Okay, similarly when you consider 3y cube plus 5y plus 7, the variable here is y. So in all the cases there is only one variable. So these are called polynomials in one variable. So using this, I can define what are polynomials. Polynomials are expressions consisting of sums of terms, each being a product of constants and variables raised to non-negative powers, in particular whole numbers, right? Okay, that is, see, polynomial is sum of terms. So you have here x square plus 2x. So it is sum of two terms here. And here you have x cube minus x square 4x 7. So here it is sum of 4 terms. Okay. And how is that each term? Each term will be product of constants and variables. A variable raised to a power. Okay. And the restriction on this power is that it should only be non-negative powers. That is, it should be positive or 0. Okay. That means it should be a whole number only. This is the definition of a polynomial. Okay, now we'll see the definition of coefficients of a polynomial. Coefficients are the multiplicative factors used with each term of a polynomial. So, for example, consider the polynomial x cube minus x square plus 4x plus 7. Okay, how many terms are there? There are x cube first term, x square second term, x third term, and constant fourth term. So you have here 4 terms. Let me separate these terms. Now you consider x cube. Here, what is the multiplicative factor of x cube? See, here you just have x cube, isn't it? You don't have any number with x cube. So it means that it is 1 into x cube. So that is the 1 is the multiplicative factor of x cube. So here the multiplicative factor of x cube is 1. And that 1 is the coefficient of x cube. So this is how we define the coefficient. Coefficients are multiplicative factors used with each term. Right? Now consider x square. Here we have minus x square. That means the multiplicative factor is minus 1. So multiplicative factor of x square is minus 1. That means minus 1 is the coefficient of x square. Now consider the x term. Here the multiplicative factor. See, here it is 4x. So the multiplicative factor of x is 4. That means 4 is the coefficient of x. Okay. Now consider the last term 7. It's just 7. You don't have any x with it, any variable with it. So I can say this is a constant term. Otherwise I can say it is a coefficient of x power 0, because we know that x power 0 is 1. So 7 x power 0 means it is equivalent to 7. We say 7 is a constant term. Otherwise it's a coefficient of x naught. Right? Okay. Now could you tell me what is the coefficient of x in this polynomial x cube minus 2x minus 5? See, what is the coefficient? How you find it? The multiplicative factor of x, isn't it? So you want coefficient of x. So you see what is the multiplicative factor of x? It is minus 2. So I say minus 2 is the coefficient of x in this polynomial. Okay, this is how we find coefficients of a polynomial. Now let me ask you some questions. Do you think minus 5 is a polynomial? See, you may think that if it is a polynomial, then you should have a constant and a variable. But here you just have a number. You don't have any variable attached to it. So you may have a doubt whether it is a polynomial or not. No doubt it is a polynomial. Okay, minus 5 is a polynomial. And of course, all constants are polynomials. The reason is that you can express this minus 5 as minus 5 into x power 0. Just now we saw that 7 can be expressed as 7 into x power 0. So like this, minus 5 can be expressed as minus 5 into x power 0 because x power 0 is 1. Okay, now you see minus 5 is a constant and x power 0 is a variable. Now it satisfies the conditions for a polynomial, isn't it? So this is a polynomial, right? Okay, and the name given to it is a constant polynomial because you don't have any variable with it. So all constants, all numbers are constant polynomials, right? Okay, now consider x plus 1 by x. Is it a polynomial? What do you think? Is x plus 1 by x a polynomial? The answer is no, it's not a polynomial. Because when you take x plus 1 by x, it can be expressed as x plus x power minus 1. That is, I have already told you the power should be a non-negative number, but here it has x power minus 1, which is, this minus 1 is not a whole number. So the exponent of the second term is not a whole number. Hence I say x plus 1 by x is not a polynomial, right? Now let's see the next example, root x plus 3. Is this a polynomial? What do you think? Is root x plus 3 a polynomial? The answer is no, it's not. Because here again, this root x can be expressed as x power 1 by 2. So root x means x power 1 by 2. And the power here is 1 by 2. This is not a whole number. So as the exponent of the first term is not a whole number, I say that this root x plus 3 is not a polynomial, right? Depending upon the number of terms in a polynomial, we can name them as monomials or binomial or trinomials. So monomial means a polynomial having only one term. For example, you consider the polynomials 2x minus 3 u power 4 minus 5 y cube. All these polynomials have only one term. See, the first polynomial, the term here is 2x. That's all. You don't have plus or minus with it. So you have only one term with all these polynomials. So the name given to them are monomials. Suppose you have two terms in a polynomial, only two terms in a polynomial, then they are said to be binomials. For example, consider these polynomials. In each of these polynomials, you consider the first polynomial, the terms here are x and 1 connected by a plus sign. Similarly, the other polynomials also has two terms, x square and x, y power 9 and 1, u power 5 and u square. So such polynomials having only two terms are called binomials. Similarly, polynomials having only three terms are called trinomials, and the examples are here. So you consider the polynomials have three terms. So first polynomial has x square, x and pi connected using plus sign. Similarly, the other polynomials. Thus, the polynomials having only three terms are called trinomials. So depending upon the terms in a polynomial, we name them as monomials or binomials or trinomials. And if the polynomial has more than three terms, then it's just a polynomial, right? Degree of a polynomial. The degree of the polynomial is nothing but the highest power of the variable in the polynomial. The highest power of the variable. That is called the degree of the polynomial. Listen to it carefully because the degree of polynomial plays a very significant role, right? Okay, now consider the polynomial 5y power 6 minus 4y square minus 6, right? Here, this is a polynomial in y, isn't it? The variable here is y. Now, if I am asked to find the degree of this polynomial, what I should do is, I should compare all the powers of y. So, here the powers of y are y power 6 and y square, among which y power 6 is the highest degree. So, I say 6 is the degree of the polynomial. So, do you understand? The highest power of the variable in a degree. That is the degree of the polynomial. And depending upon the degree of the polynomial, you can say whether it is linear or quadratic or cubic polynomial. That is, if the polynomial has degree 1, then it is called a linear polynomial. And the general form of a linear polynomial is ax plus b with a not equal to 0, because only when a not equal to 0 you have this term ax, so that you will get degree 1, and a and b are constants, of course. Okay. And similarly, if the polynomial has degree 2, it's called a quadratic polynomial, and its general form is ax square plus bx plus c, again with the same restriction, a not equal to 0, then only you will get degree to be 2 and it will be a quadratic polynomial, right? Okay. Then similarly, a polynomial of degree 3 is called a cubic polynomial, and its general form is ax cube plus bx square plus cx plus t with a not equal 0 again, so that you get the degree to be 3. So depending upon the degree of the polynomial, it can be named as a linear polynomial or quadratic or cubic polynomial. Next is the notations of a polynomial. Okay, that is, what is the symbol we use to denote a polynomial? It's nothing but just an alphabet we are going to use to denote a polynomial. Okay, together with its variable. So if the variable is x, we'll say it's p of x. If the variable is y, we'll say q of y, like that. We just use symbols, we just use alphabets to denote a polynomial together with its variable. For example, you see p of x equal 2x square plus 5x plus 3. So this is a polynomial and the symbol I use is p of x. And here for a polynomial in y, I use q of y. So one alphabet together with the variable. And if it is a polynomial in t, then I represent it as r of t. So we should also include the variable. That's very important. And here it's a polynomial in u and I take s of u, right? Okay, so this is how we denote polynomials using alphabets, right? Now let's see the general form of a polynomial in one variable and of degree n. So it is a one variable polynomial x and the variable is x. So I give the symbol p of x. Okay. And it's going to be of degree n. So the polynomial will be an x power n plus an minus 1 x power n minus 1 plus etc. a1x plus a0. And we see that all these a0, a1, a2, etc. will be constants. These are a's or all will be constants. And since it is a polynomial of degree n, this an should not be 0. That's what we saw in the quadratic polynomial and cubic polynomial and linear polynomial, that the highest degree term, the coefficient of the highest degree term should not be 0. So this an is not equal 0. And x power n, then an minus 1, x power n minus 1, likewise it goes on. So this is the general form of a polynomial in x of degree n. Right? So these are the basic introduction to polynomials. Hope you understand it better.